In this lesson, we shall focus on aspects of functional derivatives and the derivatives and slopes and gradients on functions. And we shall deal with tangents to functions, minimum gradients, and other things, concavity of functions, concave up, concave down, inflection points, and other aspects of functions that present the most challenges to learners and students alike. And first things first, we look at 7.1, and 7.1 is about determining f prime of x on first principles given that. Okay, so we look at f primed. H, which is f at x plus h divided by h. This is the limit. Okay, because the question said first principles, that is why we're doing this. Okay, first principles uses this limit concept. Okay, f primed of x equals the limit as h tends to 0 of f at x plus h minus f of x of h. I'm gonna post more practice questions on the WhatsApp group. Meaning we have x plus h, you square this, x plus h minus f of x is x squared plus x all over h. All over h. Okay, f primed is therefore the following. Right, so we'd have the limit as h tends to 0, and you square this, which means that you have x squared plus, so it is x by h by 2, which is 2xh plus, you square the h, plus x plus h minus x squared minus x divided by h, like so. Upon careful examination, we see the cancellation of x squared, but we also see the cancellation of x with minus x, leaving us with f primed of x, which is the limit as h approaches 0. Okay, we're left with 2xh, exactly h squared, plus h, all divided by h, giving us the limit as h approaches 0. H is a common factor in the numerator. Right, if h is a common factor in the numerator, we shall have therefore h, 2x plus h plus 1, all divided by h. This one cancels out, giving us the limit as h approaches 0 of 2x plus h plus 1 divided by 1. Then you can leave the division out and have exactly this. Okay, as h tends to 0, this becomes 2x plus 1. Okay, good. Okay, so the question said that determine f primed of x from first principles, if that is the case. So we then say hence f primed of x is 2x plus 1. 2x plus 1. So that in the end, that is what we're getting. Okay, next question. Now, the next question says determine f primed of x if f of x is this one here, 7.2, which is 2x to the 5th power, 3x to the 4th power, 8x. Power 1, because there's no power, I can put a 1 there on the x. We need f primed now. You have 2 by 5 to the power 5 minus 1 minus 3 by 4 x to the 4 minus 1. 8 by 1 the 1 minus 1. What is 2 by 5? 10. X to the 4. 3 by 4 is 12. X to the 3. 8x to 0. F prime of x is 10. X to the 4th power, 12x cubed, and x to the power 0 is a 1. 1 times 8 is exactly 8. The method of differentiation we use here to find the gradient here is called the power rule. It's called the power rule. Obviously, power rule in conjunction with other rules like the difference. This is the difference. So the difference rule and the summation rule. Right, so the power rule is clear that if you have f of x equals x to the power n, the implication is that the prime is nx to the n minus 1. So yeah, this becomes the answer. This becomes the answer. Right, so we're done with this question. So we have determined f prime of x if f of x is exactly that one there. So we continue. We continue. Right. Next question, 7.3. In 7.3, the tangent to g of x equals x cubed plus 3x squared plus bx plus c has a minimum gradient at the point minus 1 minus 7. For which values of x will g be concave up? For which values of x will g be concave up? Right, so let us look at these, but look at these carefully together. Now we're saying that tangent to g has a minimum gradient at this point. So let us find the gradient of the tangent. If we agree that this is ax cubed plus 3x squared plus bx plus c, the gradient of the tangent to bring down the 3. 3ax squared to bring down the 2. 2 by 3 is 6xb. So this one is the gradient of the tangent in terms of g primed of x, gradient of the tangent. Okay, if this is the gradient of the tangent, then you need to then say the tangent to this has a minimum gradient. So to find a minimum gradient of the tangent, you find the double derivative. So g double primed, okay? 2 times 3a is 6ax to the power. Subtract 1, you get a 1. The x has no power, put a 1 there. 6 by 1, it's 6x. Subtract a 1 from the x. Now you have this one is a b. B is a constant. The derivative of a constant is 0. Like here, when we find the derivative of c became 0. We don't write 0. It doesn't change anything. Here, b, we find the derivative of b. The derivative of b is 0. We don't write 0. It's standard practice because it doesn't change anything. Saying plus 0 does not change anything, giving us 6ax to the 0th power, g double primed, 6ax plus 6, because the x to the power 0 is a 1. The big 1. This is the answer. This coming week, we must go full power, full strength, all out to get the best results we need. Okay, now, the tangent to g, it has a minimum gradient. So want the minimum gradient. So the minimum gradient at this point, and it is at this particular point there. So it means, therefore, you have g double primed at x. Why? X is minus 1. Okay, and because it is minimum, it means that at the minimum or max or minimum, then the derivative must be 0. So that we have minus 6a equals minus 6. Divide by minus 6 on the left and on the right. So we continue. To continue. Right, so if you divide by minus 6, therefore it means that a is 1. Means that a is 1. So, okay, that the second derivative equals 0 for minimum gradient. For the concave up, so for concave up, the G double primed is positive. We've already got that a is 1, so which means that you're gonna substitute everything here. It's therefore gonna be like 6x plus 6. So you divide by 6. Okay, yeah, it's a this is bigger than minus 6. So you can divide by the 6 getting x bigger than minus 1. X bigger than minus 1. So they're saying for which values of x is it concave up? For which values of x is it concave up? For concave up, the second derivative is bigger than 0. For concave down, less than 0. Okay, we're good. We're so good. 8.1. 8.1. Okay, in 8.1, we have a graph. We have a graph, and the graph of y equals f prime of x, which equals mx squared plus nx plus k is drawn. Okay, this one is a parabola, but it is given in terms of the derivative. So we learned these at grade 11. Graphs and functions, they're going to be coming in the exam. Graphs and functions, they might not be so complicated, but you would have a parabola function. They will ask you the question, determine the values of m, n, and k. The graph passes through the points P, which coordinates minus 1/3, 0, Q, 1, and 0, R, 0, and 1. Okay, so we need to find the values of m, n, and k. M, N, and kappa, K. Okay, in grade 11, we're taught there's a formula we use. If we need to find the equation of this parabola, that whose x-intercepts are given, so the equation, so we study different types of the parabola function. So I'm gonna recap on the parabola graphs we studied in grade 11 and say, at grade 11, if there's a parabola like this, whose roots we know, x1, x2, then we know that the formula we use is a open bracket x minus x1, x minus x2. So, we continue. Okay, so in the end, then we have the other one we study. We have the one of the vertex. Right, y equals x minus p squared plus q. So this one is for the vertex. You want to find the equation of a parabola whose turning point you know, and then there's an extra point the examiner is going to give them. Okay, here they give you the x-intercepts, and you have an extra point to deal with there. Okay, the x-intercepts, use this one. If there's a turning point, use that. But here the examiner did not give the turning point, but they gave the x-intercept, so we're going to use this one. Right, so you're going to use in 8.1, y equals a open bracket, x minus x1, x minus x2, x1, y1, x2, y2, minus 1/3, x minus x2, x plus 1/3. Okay. Okay, this is how. Please note this. You'll practice this. I'm going to post these questions on the WhatsApp group so you can use them to practice. Okay, now this graph here, this parabola passes through an extra point. They've given us that extra point, and it is through R. Through R. So it is through R. Through the point R with the coordinates 0 and 1 together. X, Y. So the y is 1, and this is a. X is 0 plus 1/3, 0 minus 1. And this is exactly the same as what? Right, 1 is equal to, so this one is 1/3 minus 1, so minus a out of 3. We need to produce distinctions this June. So we have minus 3 times 1, we have minus 3. I need attendance this week, the whole week. Even if you are writing your other exam, you prepare the earlier so that by 8 you are available, and then we can practice. Because this June we need to make sure that we don't make any mistakes. Then we do not make any mistakes, as a matter of fact. Right, once we get a equals minus 3, then we plug everything into the equation we've got. And we're going to plug into this particular equation. So our y. Okay, our a is minus 3 here. Okay, so you have x squared minus x plus that. So let us continue. Let us continue. Which is minus 3, and then we have x by x, which is exactly x squared minus x plus 1/3 x minus 1 over 3. X squared minus 2 over 3x minus 1 over 3. Which is minus 2x minus 1. Okay, this becomes exactly the equation of the parabola we've got, but pay particular attention to the things that happen here. So we need to get the numerical values of that. My apologies there. This just jumped out of sight. Okay, so we have therefore the following. Okay, we need to get m, the coefficient of x squared. M is minus 3, n is minus 2, k is minus 1. So that's the thing. M is minus 3, n is okay, so yeah, watch the signs here. Because if you distribute, multiply by distribution, negative times negative is plus, negative times negative is plus. Okay, so we have the minus 3, 2, and then 1. And then at this point, you'll get therefore that your m, the coefficient of x squared, is minus 3, the m coefficient of x is minus 2, but the k is plus 1. Okay, plus 1. But this one, So you have +1 here, and this one is exactly 2 there. It's exactly 2 there. It's exactly 2 over there. Okay, we'll continue. We continue. We continue. So right, so we've been able to get the values here, and we remember what we got. We got m equals -3, we got n equals 2, and we got k equals 1. Okay, learn these quadratics, please, for grade 11. They're very important. And also, when you are given the intersection of the axes, they can ask you to find the equation, and you just substitute into the formula. And this is a formula not often given at the back of the exam paper, but it's something that you need to take note of, where your m is -3, n is 2, k is 1. Okay, if it is further given that f of x is this, determine the coordinates of the turning points of f. If it is further given that, so they've given us the derivative function. So this one is the derivative. They've drawn a graph of the gradient function, and they are then going on to then say, determine the coordinates of the turning points of f. Coordinates of the turning points of f. Let us find the coordinates of the turning points in 8.2.1. Right, so we already know that f of x is this one, so we're looking at the answer to 8.2.1. Right, we know that f of x is -x cubed, x squared, x plus 2. F of -1/3, which is -1/3 cubed, -1/3 squared, -1/3 plus 2. Adding everything here, gives us exactly 49 out of 27, approximately 1.81. Then we have f at 1, which is -1 cubed, 1 squared plus 1 plus 2, and therefore equals 3. Okay, so we have already, because these become the turning points. Hey, this is the gradient function, the turning points occur at the x-intercept because the derivative is 0 at this point. In other words, f prime of -3 is 0. And this, if f prime, the gradient, is 0 at that point, it means that these are the turning points of the function, because the gradient can only be 0 at the turning point, because if a graph is like this, then the gradient, the slope, is 0 of a tangent, because the tangent at the turning point is horizontal. Okay, take note of that. Take note of that. So now they want the coordinates of the turning points. So which means we will then say here there is a turning point. The turning point will occur when x is -1/3 and y is 49 out of 27. When x is 1 and y is 3. X is 1 and y is 3. Okay, so that is what we have. That is what we have exactly. So if you look at 8.2.2, we continue. So we have the coordinates of the turning points. So there are 2 of them. The turning point that is going to occur here is not. It doesn't look like a turning point. This becomes the turning point of this function. But now the original function, this one, is the cubic function. A cubic function has two turning points. Because of the negative here, of the cubic term, it means that it's going to have a maximum vertex, and so you always draw the cubic functions from the far end. Okay, you learn some of these things, and then this week I'm going to go basic and look at a lot of June exam questions in attempt to prepare, but not only June exam questions, but also sections in detail. I'll go per chapter, all questions per chapter, to make sure that you understand each chapter very well. Now, that's something that we're going to be doing this coming week. It's part of my program. You guys are not attending classes most of the time, so we need to make use of this time here. Draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts with the axis. Okay, let us draw the graph. The examiner is saying, draw this graph. Here is this graph. Draw this graph. And indicate on your graph the coordinates of the turning points and intercepts with the axis. Let us draw this graph here. Let us draw this graph here. So if this is the x and the y, so we have x is 1 and x is minus 1/3. You have already seen that when x at minus 1/3, those turning points you've already got. Okay. There, we have already got okay, like we got f of minus 1/3, we got that one. It was 49 out of 27. Minus 1/3 and 49 out of 27. Minus 1/3, 49 out of 27. Okay, and then we go to the other one. When x is 1, what did you get y to be? We got y to be 1 and 3. Go together. Okay, this is advanced, please. So I'm expecting your mind to spin, and now you just need to follow, because we're going ahead of your teachers. We are going ahead of your teachers. So it's a train smash. We're going ahead of your teachers. These your teachers, most of which have not even done this. That's why most of the kids asked me to say, can we discuss some of these things? Okay, yeah, we continue. Right, we continue. Okay, we continue. Yeah, right. So let's go back. Let's go back. So we're here, and I want us to draw this rough sketch of the graph, and then see that this graph, whenever x is minus 1/3, y is 49 out of 27. This 49 out of 27, we saw that 49 out of 27 is approximately 1,81. Okay. Minus 1, which is 49 out of 27. Okay, so there's going to be a turning point, but when x is 1, there's going to be x is 1 and y is 3. Okay, this one is like 1.81. When x is 1, y is 3, you're here, and there's going to be a turning point there. So you have this. Okay. So this one is going to be an x-intercept when x is 0. To get the x-intercept, you let x be, to get the y-intercept rather, you let x be 0, and then y is going to be this one. So y equals 2 becomes the y-intercept. Okay, which is this. Y equals 2 becomes the y-intercept. So this is the sort of graph that you're going to have. Right, so, and obviously x1, y3, and this is a turning point, and this is also a turning point. So we continue. with the analysis of these particular questions. We continue with the analysis of these particular questions. Right, so we continue with the analysis of these particular questions. Okay. We continue. Okay, yeah. All right, let's do the following. Okay, we continue. All right, to determine the coordinates of the turning points of F. Yeah, turning point there, turning point there. Draw the graph of F. We have drawn the graph of F. Okay, let me see what other thing is missing. See what other thing is missing. So this is the graph. It's going to have a turning point here and another turning point there. So now points E and W are two variable points on F prime. They're on the same horizontal line. H is a tangent to F prime at E. G is a tangent to F prime at W. H and G intersect at D, A, and B. Write down the value of A. Okay. Right, so this is a very interesting one. So you have the following. You have the following. Right, so if you look at 8.2.1, you have the points E and W are 2 points on F primed where and are on the same horizontal line. Okay. H is a tangent to F prime and E. G is a tangent to F prime at W. Okay, so let's look at what the examiner is trying to tell us here. So there's F primed, and if you look at the question, what is F primed? F primed, this is the graph of F primed, this one. So let us draw a rough sketch and see what the examiner is telling us. He's telling us some stories. Minus 1/3 and 1. Like this. So the examiner is narrating a story and it's giving us the story here. They're saying points E and W are 2 variable points. So they are movable points on F primed and are on the same horizontal line. Okay, so these are on the same horizontal line. So okay, so so now you have that. Okay, so you have this. Right, so and this is parallel to the x-axis because it's horizontal. It's a horizontal line. And this NW are 2 variable points on F primed. This is F primed, and you have the variable points there. Now, H is a tangent to F primed at E. So there's E here, there's W. And then you have a tangent, H. H is the tangent to FW to F primed at E. G is a tangent to F primed at W. So there's G, which is a tangent to F primed at W. Okay, good. Good. All right. So you have G and H is a tangent at E and G is a tangent at W. H and G, now the H and G intersect at a point, so they form some triangle there. They intersect at a point D with the coordinates A and B. Write down the value of A. Write down the value of A. Okay, that's what they want. The examiner wants, and they want us to write down the value of A. Right, so the couple of things, obviously, I mean, this point of intersection can be this one, which is minus 1/3 here, and this one is 1. So A is, this is a triangle, but now this would be symmetrical, so that one the point in the middle here, which means A is minus 1/3 plus 1 divided by 2. And this is actually the same as minus 1/3 plus 1 divided by 2. Um, um, okay, we'll continue. So yeah, you multiply this one by 3 just to eliminate this one, so that the 3 cancels out here, getting minus 1 plus 3 divided by 6, and 3 minus 1 is 2 out of 6. Okay, 3 minus 1 is 2 out of 6, and 2 out of 6, 2 goes how many times into 6? Into 6, it goes 3 times, giving us 1/3. So we're to get the value of A, and the value of A is exactly 1/3. So here, what is the value of A is 1/3. Next point, determine the values of B for which H and G will no longer be tangents to F primed. Determine the values of B for which H and G will no longer be tangents to F primed. Right. So now let us look at these, but look at these very, very carefully. Because if there are tangents there, you saw that you had this and that minus 1/3, 1, D with the coordinates A and B, and we saw that A is 1/3. So if there are no longer tangents to F primed, what do we do? There are no longer tangents to F primed. What then do we do here? We need to analyze this and think about what this means if these are no longer tangents, because determine the value of values of B for which H and G, this one is H and this one is G, right, will no longer be tangents to F primed. You see, if they are no longer tangents to F primed, it obviously means that B can take on, for example, what is value of B? What would B be? Right, so this one is minus 1/3, and this one here is 1, and therefore the total distance here is the following. The total distance is the following. Right, so the total distance between these two guys is going to be 1/3 here. This one is going to be exactly 1. So that in the end, therefore, we have that this distance is exactly 1/3 plus 1, and 1/3 plus 1 is 1/3 plus 3/3. and this is 4/3. Right, if it's 4/3 now, the distance between them is 4/3. And now if we can allow B to be such that the distance from here to there, which is exactly 4/3, and we take the same distance. Okay. Okay, yeah. So we're good. We're good. We're so good. Right. We're so good. We're so good. We're so good. Okay. Yeah, we're continuing. Right. So yeah, we're able to see therefore that if it happens now, if you add this and you get 4/3, then if we can allow B, if we can take B to be smaller than 4/3, if we can take B to be smaller than 4/3, if this is 4/3 and this is the triangle, then you take B to be smaller than 4/3, it will mean something here, as a matter of fact. It will mean definitely something there. And what would that mean? We know very well that the original function is minus x cubed plus x squared plus x plus 2. These plus 2x plus 1. Right. And that would be the case. And obviously that is going to give us, if you analyze these, and those are tangents. And these tangents, therefore, we expect them to form a triangle. So if we make this B to be much smaller than 4/3, and this graph is that way, it is expected, therefore, that this will be such that they will cut much shorter. They will cut. We're shortening the height by reducing the height. Therefore, it will cut so such that these are no longer tangents. So, okay, we're good. 1, 2, 3. Right. So now the B is going to be less than 4/3. Because if we allow B to be less than 4/3, then you're going to have exactly that part. We're going to have exactly that part there. So as a consequence, determine the values of B for which H and G will no longer be tangents. So we continue. Right. Right. So right. So in the end, then this is the answer to the question. So it's something you need to take note of. Okay, very tricky questions, some of them, but you need to put all our effort, all our strength, and get the answer to this. Okay, here's another question, but very tricky. Want to see what you're going to do here. Some of this I'm not going to ask you. I'm just going to discuss with you. Like, determine the minimum distance between the point 10 and 2 and a point on F. Right. Right, so if you're supposed to determine the minimum distance between the point 10 and 2 and the point on F. So now, let us find this. There is a function here. Let us look at this here. Okay, this one is a grade 10 graph, which has the equation f of x equals x squared. Determine the distance between the point 10 and 2. Determine the minimum distance between the point 10 and 2 and a point on F. Okay, where is this point 10? When x is x and y. See, when x is 10, okay, when x is 10, then you can do 10 squared, which is 10 squared, and 10 squared is 100. When x is 10, then y is 100. Okay, so yeah, when x is 10, then y is going to be 100 on this graph. So when x is 10, y is going to be 100. Okay, let's say I want us to just have a rough sketch of what's happening here, and then we shall solve this question. Okay, right. So when x is 10, y is going to be 100. Just look at this. X is 10, and y is x squared, 100. But this point, so this point here, when x is 10, y is 2. So there's going to be a point somewhere there. So it's going to be like somewhere here. When x is 10, y is 2. Y is 2. So when x is 10, y is 2. So that in the end, then we have the following. We have the following. Right. Right. We continue. Okay. And the examiner is asking the students, because this point here on the graph is such that when x is 10, y is like 100. So we can see the 100 there. So now when x is 10, y is 2. So this point is outside the graph, just below. And now the examiner is saying, find the minimum distance between the point these and a point on F. Take any other point on F. A point on F is x and y. So there's a distance here, and we want to find the minimum distance. We can also find, here's another point. Here's the point x and y, and want the distance. Okay, we're good. Okay, yeah, let's continue. Now, at this point, what is the distance? The distance, we've learned it from basics. We've learned the distance from basics when we're doing, so there's a point on F. See, the point on F is formed by x and y, but this function is y equals x squared, so that this is going to be x and x squared. Okay, that's a point on F. But up is the distance between the point these and the point of F. So there's the point 10 and 2. The distance. So we're interested in the distance. This is then analytical geometry. What is the distance formula? So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. We're interested in the distance. We want the distance. x1, y1, x2, y2. What is x2? X minus x1, which is 10. Y2 is x squared minus y1 is a 2. So that we have the distance. We have the distance. So the distance at this point will be given by the following. X squared minus 20. Okay, you square x, and then you multiply x times minus 10, which is minus 10x times 2 minus 20x, 100. Plus you square this one, which is x to the 4th power minus 4x squared plus 4. And this is the distance. This is the distance. So it is actually x to the 4th power. Let us order this in descending powers of x. Descending powers of x. X to the 4th power, and then we have x squared minus 4x squared, which is minus 3x squared. Okay, these two. And then we have minus 20x plus 104. Okay. So we continue. So now we're interested right now in the minimum distance. So if we know, therefore, that the distance, right, we know that the distance is the square root of x to the 4th power 3x squared minus 20x plus 104 for minimum distance. So it's d dx. So now we're gonna deal with the derivative of the expression under the square root, x to the 4th power, 3x squared, 20x plus 104. And this derivative is 0. And find the derivative of this, which is 4x cubed, 6x minus 20. Minus 20, because you find the derivative of the x. Derivative of the x is going to be x to the power 0 because there's power 1 there. You bring down 1 times 20 and then 1 minus 1. The derivative of the 1 is 0. So which is minus 6x minus 20x to the power 0, which is 4x cubed which is exactly 4x cubed minus 6x minus 20 equals 0. Divide through by, yeah, you can divide through by 2. Right, okay, you can divide through by 2, but also you can factorize this. You can factorize this. I'm not going to waste a lot of the time. By factorization, we can use the division algorithm from grade 11 called the long division method. Long division method, long division algorithm. Long division algorithm. Okay, let's write that one. And there's more science this week, please. More science, more science, more science. Algorithm. What is the long division algorithm? So you're going to have 4x cubed minus 6x minus 20. I want us to divide these by x minus 2. To divide 4x cubed by x, you get 4x squared. X by 4x squared, we have 4x cubed minus 8x squared. So we continue. So in the end, then this and that is 0, and this is actually 8x squared minus 20. So you have this 8x squared divided by x, which is exactly 8x, and x by 8x is 8x squared minus 16x. And this cancels out, giving us a 0, and this is actually plus, because negative by negative is plus, and then you have 16x minus 6, which is actually 10x minus 20. 10x divided by x, you get 10. X by 10, 10x minus 20, minus outside, 0. Okay, so the remainder is 0. That means that if you have this, you can write it as follows. You can write it as x minus 2 times 4x squared plus 8x plus 10. Okay, so we are effectively saying if you multiply these two guys, you'll get that back. So we factorized this by using what you call the long division method, or what you call the division algorithm. Okay, next. We then get the delta. So the discriminant. So yeah, determine the minimum distance for which this is the case. So we can be able to get the discriminant of this guy. B squared minus 4ac. Nature of roots, grade 11. Please pay attention. This is A, B, C, meaning that we have the B, which is exactly 8 squared minus 4A. 4C, it's 10. This is minus 96. Okay, if the discriminant is negative, it means that you have non-real roots. Non-real roots. Therefore, x equals 2 in the distance. Okay, so we continue. In the distance. What is the distance? Okay, we got the distance to be exactly this here, so we're going to put only the 2 there. 2 to the 4th power, 3 times 2 squared, 20 times 2 plus 104, 2 times 17 square root. Okay, so we have this, which means therefore D is 2 times the square root of 17, and D is approximately 8,25 units. And this is the minimum distance. This is the minimum distance. This here does not have any real roots. This does not have any real roots. Okay, so it's something you, okay? It's something you take note of. Something to take note of. Next question. In the next question, we are looking at more and more problems. But now some of these, obviously, because yeah, I'm sort of teaching this topic because from the basics, because I understand that most of you guys have not done this. Most of the students just ask me, yeah, just discuss this topic, because it is a topic that is what? That has not been done by most teachers, okay? So it's something that obviously you need to write. So we continue. We continue. We continue. We continue. Right. We continue. Let's look at this question 8, and let's spend time on it. Good. In question 8, we need to determine f prime of x from first principles if it is given that this is the case. Okay. Pay attention. Okay, we are dealing with the first principle, so f of x is the limit. As h tends to 0, x plus h minus f of x. So you have f prime of x, which becomes the limit. It's minus into x plus h squared. H. Right, so if you continue, therefore, this becomes the limit, which is minus, then you have x squared, 2xh plus h squared plus x squared. The h approaches 0. 2xh plus x squared divided by h. Okay, so this one cancels this, and this is the limit. As h tends to 0, 2xh, h squared over h. So this is the limit. Okay. And then we have h, open bracket, minus 2x minus h divided by h. So we continue. We continue. Right. Right. So at this point, then you have a cancellation law that applies, so that f prime of x is the limit as h tends to 0 of minus 2x minus h. So that as h tends to 0 is minus 2x minus this, which is minus 2x, f primed of x. F primed of x. So Robert, determine f prime of x from first principles if it is given that, so with f prime of x, which is minus twice x. Okay. So we continue. We continue. So with 8.2.1, four x cubed minus 5x squared. Right. So that now, if you want to get this, and what we said here, we use what you call the power rule. The power rule says that f of x equals x to the power n implies that the derivative or the gradient or the slope is x to the power this, and this is the derivative, the slope, or the gradient. Let's use it here. So f primed of x is given by, you have 4 times 3x to the power 3 minus 1 minus 5 times 2 to the power 2 minus 1, which is f primed of x, which is 4 times 3. And 4 times 3 is actually 12x. 3 minus 1 is 2. 5 times 2 is 10x to the power minus 1. So that f primed of x is 12x squared minus 10. And that's the answer. And that is the answer. So we're to find f prime of x from first principles. We're to find f prime of x from first principles. So we continue. We continue. We continue. We continue. So okay, yeah, there's an x here. There's an x there. Okay, so an x exists here from the previous step, so yeah, you have an x there. Now, next point, we're looking at 8.2.2 and want to find dx. dx. Let us find dx. Right, so to find dx is minus 6 the cube root of x plus 2 divided by x to the fourth power. Okay, divided by x to the fourth power. So we have the following. Right. Right, so 1/3 divided by x to the fourth power plus 2/x to the fourth power. So what we're then getting is the following. Minus 6x, so this one is 1/3 minus 4 plus 2x to the minus 4. Right, so here, we have not found the derivatives yet, but we're good enough to find the derivative at this point. Let us find the derivative at this point here. Let us find the derivative at this point. Let us find the derivative at this point. Let us find the derivative. Okay, we're continuing just now, please, to find the derivative at this point. And we have the following. We have the following. So if you find the derivative at this point, this is actually minus 6 multiplied by, okay, yeah, before we find the derivative, let us find, okay, we continue. Before I find the derivative, let us have the following. So the dx is minus 6x to, now you have this 3 by 4 is minus 12. 1 minus 12 becomes minus 11 out of 3. So that then in the end, you have 2 by minus 4, which is minus 8x to the minus 5. Okay, let's find the derivative of this. So if you want to find the derivative, we proceed as follows. We proceed as follows. 6x to the minus 11 out of 3 minus 8x to the minus 5. Minus 6, which is minus 11 out of 3x to the minus 1, which is minus 14 out of 3 minus 8. Then you bring down the minus 5x to the minus 6. Which is exactly now 3 goes how many times into 6? Goes 2 times. And therefore you have the 2, then 2 by minus 2 by 11. Right, so minus 2 by 11, then it's going to give us 22. X to the minus 14 out of 3 plus 40. Let's see now what we have. Okay, this one. Okay, yeah, check this one. It's a small typo here. This one is 2, 2, 2, and this is going to be plus 2. This one is going to be plus 2. Right, so we then continue. Okay. Okay, we continue. Okay, so continue. Right, so yeah, this is from the question 2 here. 2, 2, 2, 2. And then it's also going to be a 2 here. This one here is going to be 2x to the power minus 4. So it's just a mix-up that happened here. So let us come here. Total mix-up. So this is exactly 2 minus 4x to minus 5. Check that one. Yes. And this is going to be exactly 8. Negative is going to be exactly a negative 8. It's going to be exactly a negative 8x to the minus 5. Okay, so this becomes the answer, minus 8x to the minus 5. 22 divided by x to 4/3, which is minus 8x to the 5th power. Okay, so this is the answer. This is the answer. This is the answer. This becomes the answer. Okay, so we continue now to do the next one, to solve the next question. Right, in the next question, we have the following. In the next question, we have a graph, and this graph here is sketched below is the graph of f of x equals x cubed plus x squared plus bx plus c. The x-intercepts of f are at 3 and 0. Okay, 3 and 0 is this one. And m, where m lies on the negative x-axis. Okay, here is m. K has the coordinates. K has the coordinates 0 and minus 3. There is the y-intercept of f. M and n are the turning points of f. M and n have become the turning points. Okay, we see that. Show that the equation of f is given by f of x equals this. Show that the equation of f is given by f of x equals that one there. Let us see what that is. Okay, but remember that first and foremost, the equation of f is given as f of x equals x cubed plus ax squared plus bx plus c. Now, if the graph is given this way, it therefore means a couple of things, but it therefore means that you would have a repeated root here at this point. There's going to be a repeated root, which means, therefore, you have f of x, which is x plus t, you square it, open bracket x minus 3 to account for this. So because if it's repeated wherever the graph turns like this, such that this line is a tangent, then you will get what you call a repeated root there. Okay, now this function passes through a point. So it passes through the point K with 0, -3 as coordinates, giving us x and y. Y is -3, x is 0. Zero minus 3. We have -3, and then this is equal to -3t squared. -3, we have -3t squared. You divide by -3, divide by -3, and therefore 1 equals t squared. Plus or minus the square root of 1 equals the square root of t squared, which is plus or minus 1 equals t. At this point, it means that t equals 1. Okay. If t equals 1, then it means that we have f of x is equal to, here you put t equals 1 in this formula. So this is going to be plus 1 squared, and then x minus 3. X squared plus 2x plus 1, x minus 3. You distribute, which is x by that, which is x cubed plus 2x squared plus x minus 3x squared minus 6x minus 3. Okay, so this one here, which is actually x cubed plus 2x squared. And then we have here, okay, this is 2x squared minus 3x squared, which is just minus x squared, like here. So this is going to be exactly minus x squared. And then minus 5x. Minus 3. Minus 3. And therefore, we've shown that the equation of f is given by that. Next point, calculate the coordinates of n. Calculate the coordinates of n, so you can easily find the coordinates of n. The next question as follows. So if you have f of x equals x cubed minus x squared minus 5x minus 3, and you need to find the derivative of this to find the coordinates of n, because n is a turning point, so you need to find the derivative. F primed. 3x squared minus 2x minus 5. You equate it to 0 at the turning point, meaning you have 3x minus 5, open bracket, x plus 1, and this equals 0. Giving us x equals 5 out of 3, x equals minus 1. Okay, so we got the x values here, and obviously this one would be at the point n, we have 5/3, and you would compute and then say if ever x is 5/3 in this particular equation, you'd have 5/3, you cube that, 5/3, you square, 5/3 minus that equals minus 256 out of 27. And this minus 256 out of 27 is approximately minus 9,48, meaning the point n, therefore, will have the coordinates x equals 5 out of 3 and y equals minus 256 out of 27. Okay, so this point, the 5 out of 3 is the same as 1,67 together with minus 9,48. So this is what we have. Okay, so this is exactly what we get. 9.2, and those are the coordinates of n. 1,67 together with minus 9,48. Next point. Okay, if this is the graph we have, for which values of x will this be the case? For which values of x will, okay, here's the graph, and for which values of x will the function be negative? Where is it negative here? Okay, this is a function f, okay, shown there. But at what point will it be negative? Think about this. At what point will it be negative? Okay, it is negative when it is below the x-axis, because y is negative below and y is positive above. So if y is negative below the x-axis, so that in the end, what we then have is the following. So if f is below the x-axis, then the function is negative there. So we therefore have that. Let's analyze for what values of x will this be. Okay, so it is below the x-axis from there. Okay, it is below the x-axis from the root 3. From the root 3, because here you can see it is negative, negative, negative. The function is negative. It is negative. It is negative. For the first time, it is positive. It is above. So for what values of x is it negative, negative, negative? How do you write the answer to this? So you must then say x is less than 3, because it's negative, 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 negative. And it means that when you go to the left of 3 like this, it's still negative all the way. So x less than 3. Next. But x cannot be minus 1, because x is minus 1 here. But x is not equal to minus 1, because at minus 1, the function is 0. 9.3.2. 9.3.2. F is increasing. F is increasing. When is F increasing? Okay, increasing means that you have positive slope. So positive slope, you're dealing with the derivative. The slope is positive, but the slope is negative. And then here, the slope is positive. So in the end, F is increasing. So if F is increasing, then it's increasing because this is minus 1. Is x equal to minus 1? So, and also here we know our x is 5/3 at the is 5 out of 3 for x at the point n. So we know that is 5 out of 3. So when is f increasing? So when f is increasing to the left. So, and this is true when x is less than -1, because that is when the slope is positive. When you going like this to the right, when you proceed across the graph towards the right, you can see the function is increasing there, but it is decreasing here, and it is beginning again to increase immediately after the turning point. And that is going to happen when x is bigger than 5/3. Right. Okay. If you don't want to write your answers like this, you can write your answers not as inequalities, but as intervals in interval notation. So you can say, for example, x is an element. So this is the answer or the other one. So you can say, because if you say from -1 to all the way, from -1, you go to -infinity. So you say you start from -infinity to -1, or x is an element of this from 5/3 to infinity. From 5/3 to infinity. 9.3.3. When is the f function f concave up? When is the function f concave up? Right, so the function f is concave up when the following happens. Right, so now concave up. Concave up means that you must find the derivative. Okay, the equation, defining equation of the function is f of x equals x cubed and minus x squared minus 5x minus 3. Find the first derivative, which is 3x squared minus 2x minus 5. Okay, you bring down the 3, subtract 1, bring down the 2, subtract 1, bring down that. Concave up. Second derivative. Six x minus 2 is positive. Okay, so this is concave up. So up means the second derivative is positive. And that means that 6x is bigger than 2. Divide both left and right by 6 so that x is bigger than, you have that x is bigger than 2/6, which is 1/3. And if x is bigger than that, on the number line, if you put 1/3 and this is the x is x bigger than 1/3 is the same as saying x is an element of this. So you can say x is an element of the interval from 1/3 to infinity. Like that. Yeah. So this is true when you say concave up. Concave up means the f double primed is bigger than 0. Next question. 9.4, we're looking at the fact that determine the maximum vertical distance between the graphs of f and f primed in the interval between -1 and 0. Okay, this is -1. X is -1 here and 0. So determine the maximum vertical distance between the two graphs there. So yeah. Okay, so you have f of x, which is x cubed minus x squared minus 5x minus 3, and then you will find the derivative. 3x squared, 2x minus 5. Okay, this is a derivative. Okay, you want to find the maximum vertical distance, so the distance is x cubed, x squared, 5x minus 3 minus 3x squared minus 2x minus 5. So the distance, which is x cubed minus 4x squared minus 3x plus 2. And then you find d of the distance, derivative of the distance. So you're going to find derivative of the distance. which is dx. Okay, so the derivative of the 3x squared right, so you bring down the 3, so it's going to be 3x squared minus, you bring down 3, subtract 1, bring down 2, subtract 1, which is 8x. You have that here, the power is 1. You bring down 1, and it's minus 3x to the 1 minus 1. 3x squared minus 8x, and then this is 3 to the power 0, which is minus 3. Okay. Mm-hmm. So we continue. So the distance. So it have therefore 3x squared minus 8x minus 3 equals 0. 3x plus 1 and then x minus 3 is equal to 0, which means x is minus 1 over 3, x equals 3. So what is the maximum distance? So the maximum distance is as follows. Minus 1 over 3 cubed minus 1 over 3 squared minus 1 over 3 minus 3. You substitute into this function. We substitute into the difference function. This one here. Substituting that one there. So this is that minus 4. Need to rectify here. So the maximum is going to be exactly that. Then you have minus 4. And the x is minus 1z squared. So in the end, then which is 2,52. So the maximum distance is 2,52 units. 2,52 units. 2,52 units. So take note of that. 2,52 units. And this is the answer in terms of the maximum vertical distance. Right, so it's awesome that we had this discussed. Awesome that we had this discussed here. So this was the aspect of calculus and optimization, but we shall spend a bit more time at 8 p.m. Right.